Alrighty guys, we are looking at our special right triangles, geometric mean, and geometric or trigonomic ratios as our review for the quiz. I know it says test, should say quiz, sorry. Alright, number 1, Larry is trying to remove the car battery from his car. To remove the battery, he needs a wrench to remove a nut like the one below. The wrench size is determined by the distance across the nut from one edge to the opposite edge of the nut as indicated by the bold line. What size wrench should Larry use to remove the nut? Okay. So you see we've got a partial diagram because I don't have any other stuff over here, so it must not be important. What I do see is I have a right triangle here, and I'm pretty sure that's another right triangle there. So just mostly for size sake, I am going to draw a new, larger diagram. And let's see what we can do with that. So the first thing that I see is that I have a special right triangle. I have a 30, 60, 90 right triangle. And we did these before spring break. And if you remember from the video, the other math teacher called 30 or across from the 30-degree angle as a building block. So I'm going to call it B. The across from the hypotenuse, across from the 90-degree angle, was 2B, and across from the 60-degree angle was B times the square root of 3. Okay? Square root. Okay, so let's label our pieces here. Across from 30 is B. Across from 30 is B. Across from 90 is 2B. Across from 90 is 2B. And across from 60 is B times the square root of 3. And that shared side. I don't think I'm going to have to worry about, because what I need is this measure. I need a B plus a B, right? So if I walk from one end to the other, I go B distance, take break, and go B distance again, so it'll be 2B. Oh, hey, that was easy. I already have 2B. He needs a 1/4 inch wrench. Okay. That was a little too easy, perhaps. Okay. That's all right. We will certainly keep working on this a little bit, and let's see if I can determine B, just in case I didn't recognize that I had already gotten kind of a shortcut in there. Right? So 2B equals 1/4. So if 2B equals 1/4, and I want to find B, I'm going to divide both sides by 2, getting me B by myself. And remember that dividing by 2 is the same as multiplying by 1/2. 1 times 1 is 1. 4 times 2 is 8. So my B side equals 1/8 inch. This B side is 1/8 inch. And 1/8 plus 1/8 equals 2/8, which reduces down to 1/4. Okay. So that's where I got the 1/4 and the 1/4 inch wrench. All right. Number 2, the diameter of circle T is 12 units. Remember, diameter is from one side of the circle through the other, going through that center point. So Rabbit Sam is my diameter. I'm going to write that down. Rabbit Sam is the diameter. And I need the perimeter of RTU. From R to T to U, and back to R for that triangle. And I want perimeter, so I want to walk around the shape. I need to know how far is it from R to T. Well, from the center of the circle to the edge of the circle is the radius, and it is 1/2 the diameter. So my radius is going to be 6 units. From the center to the edge, still a radius, that is 6 units. This vertical angle here, 90 degrees. Now, what is the measure of these two angles when I need to have 3 angles added up to be 180? I know about 90 of it. And the other kind of thing you need to know is that this angle and this angle, because they open to congruent sides, are also congruent to each other. That's that base angle theorem, where the angle opens up to 6, and this angle opens up to 6. So when they open up to the same amount, they are congruent angles. If I have congruent angles, then I can match the side lengths. So that gives me a 45-degree angle here and a 45-degree angle here. I, again, have a special right triangle. 45, 45, 90, special right triangle. And if you remember from the video, the side across from 45 degrees is a building block, which means the side across from the other 45 degrees is the building block. And the side across from 90, or the hypotenuse, is going to be that building block times the square root of 2. Okay? So if B is 6 and B is 6, then B times the square root of 2 is going to be 6 times the square root of 2, or my hypotenuse. Okay? Right here, my hypotenuse. 6 square roots of 2. So if I'm walking around the angle, or around the triangle, I'm going 6 and then 6. So now I've gone 12 steps plus 6 square roots of 2. So 12 plus 6 square roots of 2 equals the perimeter of circle T. Now, I'm asked also to round my answer to 1 decimal place. So right now it's in radical form. I'm going to turn that into a decimal using my calculator. Okay. And I am going to use the square root, which is the gray control, and this x squared right underneath our trig button. That is going to give me an open doghouse. I want to say the square root of 2, and then I want to multiply that by 6, and then I also want to add 12 to it. Okay? So order of operations says I need to do the multiplication first, and then I need to do the addition. And my final answer is going to be 20.5 units equals perimeter of triangle, RTU. All right. All right. So I'm going to put a box around it so I can find it fast. All right. Number 3. What are the measures of AB and AC? Well, I'm going to label my AB X and my AC Y. That way I have something to focus on. So I'm going to solve for X first. I'm going to label my diagram. So my X side is opposite. I have data on the hypotenuse and I have theta. From my SOHCAHTOA, the equation that is going to use theta, hypotenuse, and opposite is sine. Write that down. So the sine of theta equals my opposite side length divided by my hypotenuse. I'm going to fill it in. Sine doesn't change. Drop it down. But I know theta is 25 degrees equals opposite, which is my x, divided by my hypotenuse, which is 18. Nobody likes the fractions. I'm going to handle that fraction. It's got a denominator. I'm going to multiply both sides by the denominator, giving me 18 times the sine of 25 degrees equals x. X is alone. That's good news. That's where I want it to be. I'm going to put this in my calculator just as it reads. All right, 18 times trig button, sine, insert, angle measure. And I get x is 7.607, rounded to 2 decimal places. 7.61 equals x. I don't have a unit of measure, so I should just call it units. We add that. 7.61 units is my opposite side, my AB. Okay? Let me write that down. AB equals 7.61 units. Now I'm going to target my Y. Okay? My Y is the adjacent side. Now, I could use the opposite side and use opposite and adjacent and use tangent of theta. But if I've messed this up, I'm going to mess up my next calculation. So I like to go back to my given in order to do these. Okay. So let's see, what have I got? I've got theta. I want adjacent, and I have hypotenuse. I'm going to go with the cosine of theta equals adjacent divided by hypotenuse. So the cosine drops down. Theta I am given is 25 degrees equals my adjacent, which is y, divided by my hypotenuse of 18. Again, I got to get rid of that denominator because nobody likes working with fractions. Leaving me 18 times the cosine of 25 equals y. Y is by itself. Good news. I'm going right to my calculator. Entering it in. 18 times trig. This time I'm selecting cosine. Still inserting 25 degrees. Hit enter. I get 16.31. 2 decimal places. Units equals y. Put a box around it. That is AC. So AC equals 16.31 units. Okay. I have found my X. I have found my Y. I'm good to go on to the next one. Okay. All right. Number 4. I want to tell you, number 4 is interesting, right? We are to find the measure of x in simplified form as a radical. That means we are going to need a doghouse kind of answer. Most likely. It should not be in decimal form. Okay. And for this one, my visual noise issues kick in. So I'm going to separate these into two different triangles so that I can focus on them one at a time. 12, 60 degrees. My other triangle goes like this. And this is 45. And this is my x. If I need x, that's in this lower triangle. This is 45 degrees. 90. That means this has to be 45 degrees. 60 plus 90 plus 30 is 180. Let me transfer those findings. So this side, let me mark it in purple, and this side in purple are the same side. Okay? But they're used in both of those triangles. Okay? So I need to find this side, and I need to find this side. Unless I can figure out a way to make 12 part of this, I don't know, it's a quadrilateral, but that's all it is. Okay. So what I'm going to do is I'm going to find this shared side, this purple line, and that should give me enough information to solve for x. Okay. Across from my 60-degree angle is 12. So 12 equals the side, the building block, times the square root of 3 in a special right triangle. Across from 30 is the building block, and that hypotenuse is 2 times the building block. I need B. I got to have this building block number. Okay. Now from the video, and I like the way he did this, he said the square root of 3 times something has to give me 12. But that something, let me make my parentheses a little bigger, has to include the square root of 3 because it's got to fall out. Square root of 3 times the square root of 3 is 3. Something times 3 equals 12. That number is 4. 4 square roots of 3 times the square root of 3 will give me 12. So my B, my base, my building block, is going to be 4 times the square root of 3. So 4 times the square root of 3, across from my 30, my building block. And I need this hypotenuse. That hypotenuse is 2b. So 2 times 4 square roots of 3 equals 8 square roots of 3. Okay. Excuse me. So I'm multiplying by this entire expression. They are not in pieces. Okay. So here is my hypotenuse. Let's fill it in. 8 square roots of 3. 4 square roots of 3 is on this side. Should probably go ahead and label that one here as well. So now my purple line, 8 square roots of 3, opens to 45 degrees. Guess what? 45 degrees opens to the same measure. Okay. My hypotenuse for a 45, 45, 90 right triangle is my building block times the square root of 2. Here's my building block. 8 square roots of 3 times the square root of 2 equals 8 square roots of 6. Okay. 3 times 2 is 6. And 6, because it breaks down into 3 and 2, I don't have any pairs to get out of the doghouse. So my final answer for the side marked X is 8 square root of 6 units, because I don't have a unit of measure. Okay? So 8 square root of 6 units is my final answer for number 4. It's a lot. I know. You're all right. Number 5, a 21-foot ladder is leaning against a wall. Ladder. 21 feet. The angle formed between the ladder and the ground is 31 degrees. Find the horizontal length between the base of the ladder and the wall and round it to the nearest hundredth. You guys recognize that the wall and the ground make a right angle. Okay. So I have an angle and a side. I'm going to use trig. Theta, my hypotenuse across from my right angle, opposite side, and adjacent side. I have data on my hypotenuse, I have data on adjacent, and I have theta. My SOHCAHTOA says that I should use the cosine of theta equals adjacent divided by hypotenuse. So now I'm just going to fill in what I've got. Cosine doesn't change. Theta is 31 degrees. My adjacent side is my x, so I should probably label it x, right? X divided by my hypotenuse of 21. Nobody likes the fractions. Let's handle that fraction. Multiplying both sides by 21. 21 times the cosine of 31 equals x. X is alone. That's good news, because now I can just go to my calculator and input that information. 21 times trig button cosine 31 degrees. Enter. I get 18.0005. How many decimal places? 100th. 2 decimal places. And that is in feet. Feet. 18 feet is my horizontal or adjacent side value. Don't forget that unit of measure. Okay. Number 6, find the measures of x, y, and z using the diagram below and the geometric mean. Round your answers to the nearest 10th place. Okay, I gave you a hint at the bottom. Label your diagram. 50 is the hypotenuse, broken down into side 1 and side 2. I'm going to call x side 1, y side 2. And that attaches itself to leg 1 and leg 2. From the original big right triangle right angle to the hypotenuse is my altitude, or my A. Grown-up word for height, altitude. Okay. Now I'm going to pick a target. I'm going to go with X. Why? Because it came first. X in its little box. Excuse me. All right. Which side is X? S1. I see that I have S1 used in these two proportions. How am I going to choose between them? Okay. Well, I'm going to find out if I have the information needed. So, I'm looking at this one. Hypotenuse. Yep, I have the hypotenuse. Leg 1. Yep, I've got leg 1. Leg 1. Yeah, I've still got leg 1. Side 1 is what I'm looking for. I'm going to use that proportion. Hypotenuse over leg 1 equals leg 1 over side 1. Filling it in. 50 divided by leg 1, 30 equals leg 1, 30 divided by my side 1, which is currently x. I'm going to cross multiply. 50x equals 900. X, I believe, is 18, but I'm going to double check on my calculator because y'all know I can't always work that way. All right. So 30 squared, 900 divided by 50, 18. And it's units. Okay. So side 1 equals 18 units. Putting a box around it so I can find it fast. Going on to target the y. Y is side 2. Side 2 is used in this proportion and this proportion. Same question, how do I choose between the two? Well, I don't have an altitude. That's going to make this difficult. Okay. Now, I could use this one if I'm willing to bet that my side 1, 18, is true and correct. I could take my chances. Okay. No, I couldn't because I still don't have an altitude. Sorry. Never mind. This is the one I'm going to use. The hypotenuse divided by leg 2 equals leg 2 divided by side 2. What have I got? I got a hypotenuse of 50. I've got a leg 2 of 40. I've got a leg 2, still 40. And that is divided by side 2, or my y. Okay. Cross multiplying again. 50y equals 1600. So y should equal 32. Double checking with my calculator. 40 times 40, 1600. 1600 divided by 50 gives me 32. I like that. Units. Okay. So side 2, my y is 32 units. Now, how about my z? That's that altitude. I only have one that uses the altitude. So guess what? That's the one I'm going to use. But in doing so, I'm going to be forced to use my calculations for side 1 and side 2. So hopefully we did these two right, because I'm about to use them again. So side 1 divided by my altitude equals altitude divided by side 2. Side 1 I calculated as 18. I am working on the altitude equals altitude divided by side 2, which I thought is 32. Cross multiply. I have no idea what 18 times 32 is. 18 times 32. 576 equals a times a, or a squared. So I'm going to take the square root of both sides and get 24 units equals my altitude, right? Square root of both sides. So that is my z value, 24 units. Right? And it says round your answers to the nearest tenths place, but I don't have any leftovers. Okay? That's all right. We're good. To me, even though it says round to the tenths place, 32.0 is really just cluttering stuff up. Okay? And you know me with my visual noise issues, clutter is a problem. So if 0 doesn't add any value, I'm not going to write it. Take that out so it don't have something random running around on your paper. Okay. So I should probably make this Z as in zebra, right? All right. Yep. Okay. Next one. Solve for theta. Round our answers to the nearest degree. Recognize that this degree is a whole number. Okay. Let's label our diagram. Across from my right angle is my hypotenuse. Across from theta is opposite, leaving me the adjacent side as the third side. I have data on the adjacent and the opposite, and I'm asked to find theta, that angle measure. So if I go to my SOHCAHTOA, the only one that uses both opposite and adjacent is the tangent. So the tangent of theta equals opposite divided by adjacent. Let's fill in what we know. Tangent doesn't change. Theta, my unknown, just dropping it down because I still don't know, equals opposite side 10 over adjacent side 15. And remember, guys, once you have that ratio and you are going back to get that angle measure, you're going to use the -1 function in your calculator. All right, so I am going to trig button. Instead of the regular tangent, I'm picking tangent -1. I am entering in this ratio, 10 divided by 15, hitting enter. Theta equals 33.6 degrees, but I got to round it up, okay, because I want it to the nearest degree, and that is going to be my final answer, 34 degrees. Number 8. Oh, goodness, we are almost done. After striking out, a softball player leaned her bat against the fence of the dugout. What is the angle formed between the ground and the baseball bat? This angle. And again, we are to round it to the nearest degree. Okay? Let's label up our diagram. Across from the right angle, my hypotenuse. Okay? Across from theta is opposite, leaving my last side to be adjacent. All right. What do I need to figure out? I need to figure out, using SOHCAHTOA, who uses adjacent and hypotenuse. Well, that, Miss Hart, is the cosine of theta. Oh, you know what? I should probably mark the theta. That's my x. Equals adjacent divided by hypotenuse. All right, cosine doesn't change. Still looking for theta. My adjacent is 17. My hypotenuse is 28. Once again, I have the ratio. I'm going back for the angle. I'm going to use that -1 function. All right, so trig button, cosine -1 this time. Enter in that ratio, 17 divided by 28. Hit enter. Theta equals 52.6. That rounds up to 53 degrees. That is going to be my final rounded answer. Don't get scared by the word problems. They're not that big a deal. Number 9. Okay. Round my answer to the nearest degree. I'm asked to solve for theta. Okay. Guys, I didn't put that this is a right angle. So across from the right angle is the hypotenuse. Across from theta is the opposite side. Maybe my third side to be adjacent, even though I don't have any data. Okay. I've got the opposite and the hypotenuse. The only ratio that uses opposite and hypotenuse is the sine. So the sine of theta equals opposite divided by hypotenuse. So the sine doesn't change. Theta is what I'm looking for, equals my opposite side divided by my hypotenuse. Now then, got the ratio going back for the angle. I am going to use sine -1 here. Oh, no, that's not what I wanted. Come on, little machine. There we go. Okay. So trig button, sine -1, insert the, whoops, 14, the ratio, and I get 12.37, but I want to round that to the nearest degree. So theta equals 12 degrees. Don't forget that unit of measure, 12 degrees. Last one. All right, solve for x and round to the nearest thousandths place. I'm not sure how many decimal places that is. So tenths, hundredths, thousandths. I need the third decimal place. Okay, now that I know that, I can continue on. Solve for x. I have a theta. Across from theta is opposite. Across my right angle is hypotenuse, leaving me this to be adjacent. I have theta opposite. I want adjacent. So I'm going to use the tangent of theta equals my opposite side divided by my adjacent side. And now I'm going to fill in what I've got. Tangent doesn't change. Theta I'm given is 34. The opposite side is 7 divided by a, which is my x. Good. I've got that pesky denominator again. Multiply both sides by the denominator, giving me x times the tangent of 34 degrees equals 7. But I want x alone. It is being multiplied by the tangent of 34. So to undo it, I'm going to divide by the tangent of 34, and I am going to do that on both sides of the equal sign. So the tangent of 34 divided by the tangent of 34 reduces down to 1, leaving me x equals 7 divided by the tangent of 34 degrees. Okay, x is by itself. I'm going to my calculator. All right, and I'm putting it in just like I see it. 7 divided by the tangent of 34 and hitting enter. And I get 10.3779. 10.3779. And that is in units. And I need it to 3 decimal places. 1, 2, 3. So 9 is big enough to make 7 scared and jump up. So my actual boxed final answer is 10.378 units. That is my final answer for the side marked X. Okay, all right with that. Okay, so you are, what video? Oh, didn't stop it.